Okay, moving into chapter 3. Before we do, I wanted to make sure I included this one more question from chapter 2. So we did number 9 already, but let's add this one, number 10. Um, we need to be able to graph absolute value functions that, or any type of function that has a less than or a greater than sign. So I want to make sure that you remember that that means that we are going to be shading. Okay, so this one just happens to be a V-shaped graph. The reason it's a V-shaped graph is because it is an absolute value problem. Otherwise, it would be like a y equals some x plus b, and it'd be a straight line. So that means I need to find the vertex. The vertex is opposite of the inside and exactly the number on the back, so +3, +4, and the slope is the number in the front. In this case, it's a 1/1. So the first thing I'm going to do is graph my shape. Now again, if this was a straight line, you would be graphing a straight line. It just so happens that this particular problem is a V shape because it's absolute value. So 3, 4 is there. Slope 1/1. Remember, this is not a straight line graph. This is a V-shaped graph, so I got to go 1/1 in both directions. Also, please remember this is a broken line because it is not equal to, and I'm going to shade below my whatever I draw. I'm going to shade below because it's less than. So you've got to keep an eye out for V-shaped graphs. Let's see, I think I've got broken lines here. Let's go ahead and do that. All right, got another broken line here. Good, let's connect it up. So anything on that line is not considered a solution. Anything below that line, it's just where I'm going to shade, would be considered a solution. So I got to go below, that's anywhere underneath of the broken line. Let's see. Underneath the broken line, not including the broken line. Underneath, but not including the broken line. So everything that I'm shading is a solution to that particular problem. So if you plugged in, for example, if you plugged in 0, 0, you would get a true solution. So that's how you handle it. Make sure you just can shade straight lines and absolute value graphs with shading. Now we really will go into chapter 3, which again is going to actually involve some more shading problems, double shading problems. Chapter 3 is all about when you have more than one equation, you have to set them equal to each other. So this type of problem is a 3x3, and you can use this website if you want to, if you can remember where it's found. It's in the 3.5 folder. Now, I'm going to make sure you guys all understand, I am not going to be providing, oh, that is not a clickable link. That's unfortunate. I guess I'll have to show you where it is in the folder. Hope that I don't have grades pulled up. All right, so that would have been finish chapter 3. It's in the 3.6 folder. Change that to say 3.6 folder. Matrix calculator. I'll change that hopefully so for you guys. Number of rows, that's how many up and down. So it would be 3 up and down, and it would be 4 because 3 is how tall it is, 4 is how wide it is. We're going to have to submit it. Now, oh good, I can dual screen here, so I'll go ahead and pull Notability up. You can do this. This is from 3-5 if you want to do it by hand. There's certainly nothing wrong with doing this by hand. Let's see, -2, 1. These are just the coefficients, -1 and -8. 2, 2, so 2, 2, -1, and -3. I am pulling these numbers from the lines beside it. If you look, you can see their coefficients are in front of it. 7. Hit submit. They're going to do all this matrix stuff for you, and the final box is your answer. The top number is X. The next number is -3. Last number is 1. Now, there is no doubt that some of you have utilized PhotoMath to the best of your ability. Please understand that I will be making it so that you cannot take a picture of these particular type of problems. So you're either A, going to have to know how to do this by hand, or from using the website in the 3.6 folder and bookmarking it yourself. I will certainly not be providing it during the final. You have to have your tools ready to go, okay? Now, let's go ahead and do number 2. It says without graphing, classify it. Now, when they say classify it, you're going to use one of these words. You're going to use independent, you're going to use dependent, or you're going to use inconsistent. Okay, this is from chapter 3, section 2, if you need to look that up. So it says before you graph it. It says, okay, before I graph it, so you know what I'm going to do? I'm going to use some substitution. I'm going to set that equal to that. So I get 4x minus 6 equals 2/3 x plus 4. And I got to solve for x. I'm going to add 6 to both sides. 4x equals 2/3 x plus 10. I'm going to subtract 2/3 x. Now, if you're not sure what 4 minus 2/3 is, and you got your calculator, so you can do 4 minus 2/3. Definitely change it to a fraction, so 10/3. So that's 10/3 x equals 10. Multiply by 3. I'm just solving for x. So I get 10x equals 30. Divide by 10. X is 3. So I'm getting an answer. See how I got like x equals 3? That's automatically independent. It's ENT. The reason it's independent means you get an answer. Dependent means your x's and y's cancel out and you get like 4 equals 4. Inconsistent would mean your x's and y's cancel out and you get like 4 equals 10. So let's go ahead and plug that in, find for y. So let's use the easier equation. Y equals 4x minus 6. Let's take out that x and put in 3. So it'd be 12 minus 6 is 6, so y is 6. So since I got an actual answer, I'll label as independent. You might want to review what the other two mean. Now it says go ahead and like graph them and solve them. So they're both equal to y. So I'll color code them for you. Maybe that would be helpful. I will do this one in blue. I'll do this one in green. Okay. So I'm going to go down 6, 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. I like to get as many as I possibly can. It helps me to see it better. Looks pretty good. Green now. They're already solved for y. P.S. If they were not solved for y, you would need to do that. 1, 2, 1, 2. Oh, good. See how I hit? My green hit my blue? That's good. That means I'm done. Okay, so it says then find the solution by using a graph. And sure enough, look at that graph. It does, in fact, and it should cross at over 3 up 6, which is exactly what I got for my x and my y. So there it is using your graph. So let's just make sure you understand. Independent means you get an answer. It also means that the graph, it's going to cross or it's going to intersect. Now, so maybe you're thinking to yourself, okay, that's great that's what that problem is. What if it was dependent? Dependent means that they would be the same exact line if you were graphing them. And then inconsistent would mean that they are parallel. Okay. And then, like I said, independent means that they cross or they intersect. Okay. So there you go. We solved it. Now, number 3, solve the system. We can solve however we want. I like how this is lined up. Personally, this looks really good for elimination. We call this a Mr. Travel Piece trick, where you do this and this and this and this. Coefficient here, like they mix and match, right? Like that goes there and that one goes there. And then 3 out of 4 of them have to either be positive or 3 out of 4 of them have to be negative. So we're going to go boink, boink, and boink, 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 and boink. Mashiri's laughing at me. Negative 1a minus 1b equals negative 1/3. Positive 1a minus 1b equals positive 1/4. The a's cancel. The b's make negative 2b. And some people think those b's probably would cancel. Let me screen share my calculator so I don't have to keep going back and forth. Negative 1/3 plus 1/4 so negative 1/12. And then I have to take negative 1/12 and divide by negative 2. Oops. You can put that in parentheses if you want. So I get positive 1/24. So B is positive 1/24. Nothing wrong with that. We're right. So that would mean A, we're going to have to plug it in to find A. So you can solve it. Now this, again, you can use that website that I gave to you in the 3-6 folder. You're more than welcome to do that. I am going to at least solve one of these by hand for you. Your choice. If you're going to have your tools available, that's fine. Be able to type inside. Just remember, photomath will not be an option because I have found like a hack to get rid of that. Okay, so I'll do x plus, I'm going to start with, yeah, I'll start with this one. Why not? Doesn't really matter. And I'll solve for x. So x plus 2y. Some of you might be thinking then I'm doing this the difficult way. I am. A lot of you might be able to eye up to start with that one. That's totally your choice, though. I'm just going to stay consistent. Some people like just one set method. So take the first one, solve for a variable. I'll solve for x. So negative 2y minus z plus 14, middle column. Put this in for x. So I have y equals z plus 1. There's no x to sub in for, so just take the z to the other side. So I'll do y. I'm putting it in standard form. Okay, so that's it. Now this one, x minus 3z plus 6. Oh, equals, silly me. So I'm going to take that big box, put it in for that x. This one's a little more cumbersome, isn't it? So negative 2y minus z plus 14 equals negative 3z plus 6. I'm going to take my 14 over here to my 6 and take my 3z over here. I'm getting it in standard form. We always did that when we did these problems. This was chapter 3, section 5. Negative 8. Okay, so what I want you to see about this one and this one is that they're both in standard form, and because we got rid of the x in the third equation, they both have a y and a z. So I can put the second equation underneath of the first equation and do the Mr. Travel Piece trick. In other words, elimination. So I'll zoom in so I have maybe neater handwriting for you. 2 down here, 1 up here. Now let's check our signs. Positive, 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 negative. So 3 positives, 1 negative is good. All right, that's going to be, I probably have room to write it on the side, but I guess, yeah, I'll write it to the side. I'll zoom in. Distribute a positive 1. It's going to give me negative 2y plus 2z equals negative 8. Positive 1 doesn't change anything. 2y minus 2z equals 2. And that was from me distributing here. The y's cancel as they should. Oh, look at that. The z's cancel. That's bizarre. So I actually get 0 equals negative 6. This is a no solution problem. I'm going to guess if I did type this into that one website, it's going to say no solution. I am going to double check though, because it does seem a little odd. Make sure I'm not wrong. Let's hit the, oh boy. Let's go to Schoolage. There it is. So this is from the 3.6 folder, if any of you are wondering. I'll hit the back button. Okay, ooh, hit the back button again. Okay, so this one's going to be, yep. Ooh, not going to be pretty. All right. Oh, you fast forward all you want, guys. If you want to fast forward, fast forward. Clearly I solved it already. Hopefully I'm right. So I don't have to waste any time. So I got to get them all in the correct form. So I can put that one in. This is going to be how many rows? 3 tall, 4 wide. Okay. So I got to get this one. This one's going to be y minus z equals 1. This is for the calculator. And this is going to be x plus 3z equals 6. I have to get them in standard form to use this website. Okay, so my numbers are going to be 1, 2, 114, 1, 2, 1, 14. How am I doing that time? 10 minutes to my next class. No x on this one. So 0, 1, negative 1, 1. Okay, x, 1. There's no y here, so 0, 3, and 6. Let's hope that it says no solution. Okay, yeah, it's not going to allow me to do it. All right, so this is kind of hard. Remember, I don't know if you do remember, but whenever I have to take a screenshot to write on it, when we did reduced row echelon form, if these numbers right here were not a diagonal of ones, this is not a possible problem. So that is not a diagonal of ones. So this is an impossible problem. Sorry, Charlie, no luck, cannot do this particular problem. It has to be a diagonal of ones. If you rewind the video, you'll see like on the one problem we did that sure enough, we got a diagonal of ones there. So that is an impossible problem. Okay, number 5. I got 10 minutes in my next class. I can do this. Roast beef has 25 grams of protein, 11 grams of calcium per serving. A serving of mashed potatoes has 2 grams of protein and 25 grams of calcium. How many servings of each are needed to supply? Okay, so how many servings of each? That means my roast beef is going to be everything that has to do with X because we're talking about each. So they're asking about roast beef and they're asking about mashed potatoes. Okay, so roast beef is going to be my X, mashed potatoes is going to be my Y. Okay, to supply exactly a total of 29 grams of protein and 61 grams of calcium. That means I am going to have a protein equation, and I'm going to have a calcium equation. So they asked me about, they didn't ask, the question was not asking about protein and calcium. The question's asking about how much roast beef and how much mashed potatoes. That identifies what your X and Y are. So let's go ahead and do protein. Okay, so X, protein, 25. So there's 25 grams of protein in roast beef and 2 grams of protein in mashed potatoes for a total of 29 grams of protein. Calcium. We've got 11 grams of calcium in roast beef and 25 grams of calcium in mashed potatoes. Whoopsie. There you go. Total of 61. This is set up extremely well for elimination. So I'll do the Mr. Travel Piece trick, where I do 11 and 25. Make one of them negative. And distribute. Oof. Okay, here we go. Negative 11 times 25 is 257. I think it's 275. We better double check though, because you don't want me to get that wrong. 11 times 25, 275. Okay. So it's negative 275x minus 22y equals, we better just double check this. If I get this wrong, I'll have to redo the whole video. Okay, here we go. So I'm doing 11 times 29, 322, 319. So negative 319. Okay. And now let's distribute 25 into there. So this is going to be positive 275x. And 25 times 25 is positive 625. And 25 times 61 is 1525. So those cancel, and 625 minus 22 is 603y equals 1525 minus 319 is 1206. And divide that out, I think you'll just get 2. Yep, I just thought I'd say 2 because I know it's 2. Okay, so for y, that means 2 servings of mashed potatoes. And then roast beef, we just had to plug that in and solve. So I'll just use 25x. I'll do 25x plus 2 times y equals 29. 25x, that would be 4 equals 25. X equals 1. So that would be of roast beef. All right, so 2 servings of mashed potatoes, 1 serving of roast beef. We'll take care of it. And honestly, you guys probably could have digested that through reasoning skills is probably my there. Just in case it was decimals, though, it would be really hard, so you should know how to do it otherwise. All right, this is it for chapter 3. Some more graphing. Now we're really coming back just to the straight up math. This one is going to be a V shape because it's absolute value. This one is going to be linear. meaning a straight line. So let's get rid of the V shape first. I will color code green and color code blue. These are both shading problems because they are inequality. So let's do the V-shape one first. So that is going to be green. So the V-shaped graph has a vertex and it has a slope. The slope is the number in front of the absolute value. In this case, you could pull that 5 out. And what is inside being added or subtracted? 0. What's in the back? -1. So we are going to plot our point of 0, -1. Go up 5 over 1. 1, 2, 3, 4, 5. Make sure you make it a V. Don't make it a straight line. And let's see, this is also going to be broken. And I'm going to shade below because it's less than. It's broken because it's not equal to, in case you forgot that. Let's see, I got a little broken thing here. Oops. Shade below. All right, now for the blue. So the blue is linear, so I'm going to draw a little quick arrow here. Oops, let me make that solid for you. So the slope, this is just a straight line. The slope is -3 over 1, and the y-intercept is 7. You guys know that. So 7, 1, 2, 3, 4, 5, 6, 7. Down 3, 1, 2, 3 over 1, 1, 2, 3 over 1. Straight line, this is solid. The line is solid, and we are going to shade above. So solid line. Oops. Oh, I messed that up, didn't I? Get nervous. I want to make sure I get to my class. I got a couple of minutes. Okay, there's my line. Shade above it. So the answer, if you want to darken it in, which I would probably encourage you to do, is where the blue and the green intersect for that pretty teal color, which is everything here, including the blue line, but not including the green line because the green line's broken. So that stuff there is the fine. Anything that's in that double pretty shaded teal area answers is a solution overall to both of those equations. So key points, make sure you know elimination and substitution. Make sure you can graph. Make sure you know the difference between straight lines versus V's. And make sure you know how to use that website unless you like that 3-column method. I don't know many people who do. And please remember that photo math will not be a thing on the final.